So 6.3 y'all talks about something called the law of sines. And so it says the law of sines applies in cases where the known angle and the opposite side form a complete ratio, like A over sine of A. So it says the law of sines can be used for cases in which a complete ratio is not given. So when we have two sides and angle between them, or we have all three sides. And so we have a couple of different sort of formulas or expressions for the law of cosines, and that's what I have right here. Okay. So let me ask you all a question. Look at this one right here. What does this part right here look like to y'all? Pythagorean theorem, right? Remember the Pythagorean theorem back in geometry? A squared plus b squared equals c squared. Okay. So the Pythagorean theorem, y'all, is just a special case of the law of cosines. So let's call this A, B, C. This would be little c and little b. And so Pythagorean, actually, I should probably, well, that's okay. We'll do it like this. And actually, it was more this one right here, right? I think that's one that looks more like the Pythagorean theorem. C squared equals A squared plus B squared. So, let me fix this triangle just so that it looks like the other one. And let's call this side here that angle A. So this is little a, big C, and little c. Okay, so when you're doing the Pythagorean theorem, right, here's my right triangle, right? So you'd say c squared equals a squared plus b squared, and then it has this minus 2b cosine c. Does anybody remember what's the cosine of 90 degrees? So remember, if I'm thinking about the unit circle, remember this is the point 1, 0, this is the point 0, 1, this is the point negative 1, 0, this is the point 0, negative 1, back to point 0. So 90 degrees would be right here. So this is the point, x is 0, y is 1. Does the cosine use the x value or the y value? The x value. What did we say the x value was here? 0. So if the x value is, if the cosine of 90 degrees is 0, then this whole piece just goes away, right? And that's how we get the Pythagorean theorem. So the Pythagorean theorem is just basically like a special case of the law of cosines. Okay. So let's keep moving along here. So we're going to solve a triangle using the law of cosines. What's going on, Thomas? And it says guidelines for solving an oblique triangle given the side angle side. So it says we're going to find the length of the side opposite the known angle by using the law of cosines. And then we're going to use the law of sines to find the measure of the angle opposite the shorter of the two given sides. And it says this angle is always going to be acute. This will not involve the ambiguous case. Or we can use the law of cosines in its alternative form to find the remaining angle. And then we're going to find the measure of the third angle by subtracting the sum of the measures of the other two from 180. So let's see what they're talking about here. Let's go through the process looking at step number 1. We're going to find the length of the opposite side of the known angle using the law of cosines. So what we want to do, we want to look for A, because we already know this angle A, and it's telling me we need to find the length of the side opposite the known angle. Okay, so y'all, I'm going to write down the law of sines. A squared equals, or law of cosines, A squared equals B squared plus C squared minus 2BC cosine of A. And all I'm doing here, y'all, I'm just using this part right here, right? All I did is copy that, kind of, so you can see what I did, right? All I did is just write down the formula. Okay, so now we want to find the side A using the law of cosines. So let's go ahead and do that. We should be able to do this simply by plug and chug. Okay, so A squared equals B squared. B is 19, so 19 squared plus C, which is 22 squared, minus 2 times B and C, 19 and 22, cosine of how much? 38, thank you. Okay. And so first thing I'm going to do here, y'all, I'm going to grab my calculator. Let me turn it on, clear it out. I want to make sure that my calculator is in degrees, right? So I'm going to go to mode, and yes, I'm still in degrees. We were in degrees when we did the law of sines on Monday, but we're still in degrees here. Okay, so let's take this. We're going to go slowly. 19 squared plus 22 squared is 22. Okay, minus 2 times 19 times 22 times what, the cosine of 38. Okay. And so I'm coming up with this value right here, but that's giving me what? That's giving me the square of the number, right? Because that's a squared. So remember, it's a squared equals all this stuff here. So in order for us to find a, what do we need to do with this number? Take the square root. So we're going to go second square root of our answer. And I think it's telling me to go to one decimal place. So would you say 13.6 or 13.7? 13.6. Okay. So we came up with a equals 13.6. So right here, 13.6. Okay, so the next part 2 says, look, we're going to use the law of sines to find the measure of the angle opposite the shorter of the two given sides. So the two given sides that we already had, y'all, were what, 19 and 22. Which is the shorter of the two sides? B, right? So we're going to find the angle that's opposite of that. So remember how we use the law of sines? We're going to go sine of B over little b equals, I'm going to use sine of A over little a because we already know the angle A and we know the side A, and we don't know anything about C. I mean, we know the side C, but we don't know the angle. Okay, so we're going to go slow here. We're going to go sine B over little b, which was 19, equals the sine of A we said was 38, over little a, which we came up with 13.6. Okay. And we're going to multiply everything by 19, so we can cancel that out. So that's going to leave me with the sine of B equals 19 times the sine of 38 degrees over 13.6. And then to find B, we're going to take the sine inverse of all this fun stuff. So again, I'm going to grab my calculator and we're going to go slowly. So we're going to go second sine inverse 19 times the sine of 38 degrees. So y'all, one thing I want to mention is use whether you're using a calculator or whether you're using the calculator app. If your calculator, like my calculator here, this is an older version, right? This is the TI-83 Plus. This thing opens up parentheses for my angle. So I need to close those parentheses off, okay? And then I'm going to divide that by 13.6. And then I need to close the parentheses for the whole expression too, okay? So don't forget, if your calculator does open up parentheses, or if you need to open up parentheses on your own, make sure you do so. Then we're going to hit equals. So we're coming up with B. Guys, one decimal place, 15 or 59.3 or 0.4. Okay, so good. We're going to go 59.3 degrees. Now, I want to point something out. Look what it says here. We have it underlined. Look what it says right here. This angle will always be acute. Remember what acute means? It's smaller than 90 degrees, right? Between 0 and 90. This will not involve the ambiguous case. So on Monday, we were doing some problems, and we actually ended up with two triangles. It's telling me here that I'm not going to get two triangles. I'm always just going to have that one acute angle, okay? All right, so we did that part. And, oh, we did it over here. We actually did step 2 already. That right there. Step 3, we need to find our third angle, okay? So I'm just going to zoom out real quick, and then we'll come back and take a look. So we already know that angle A was 38 degrees. We found angle B to be 59.3 degrees. We need to find angle C. So everybody agree we're just going to take 180 minus the sum of those two, because we know that when we add up all our angles inside a triangle, it has to add up to 180 degrees. And coming up with 82.7. So far, we done okay? I'm sorry? You didn't get 82.7? Or you didn't get 59.3? So you put in what? 19? Oh, you put in that whole value there? Yeah. Yes, it is. But remember what we're doing. We're rounding as we're going along, right? So we're rounding as we're going along. Then do you want to use the value that we got from there? Yeah. Well, typically we would, but again, if it's telling you, like in the problem, if it's telling you to round and then use your answer from the previous part to get the next one, then you want to definitely use the rounded answer. But you're right. Yours is going to be more precise because you're not rounding, or more accurate, or whatever. Do I need to stay on the same page? Are we good, John? We're good? Okay, just check. All right, so let's take a look at the second problem we have here. Solving a triangle using the law of cosines when we have all three sides. It says use the alternative formulas for the law of cosines to find the largest angle of the triangle, the angle that's opposite the longest side. Okay, so let me ask you a question. Looking at the picture, what is the longest side here? Out of my A, B, and C. C. Okay, so that's the angle that we're going to find. We're going to find the largest angle of the triangle that has, we're going to find the angle opposite the longest side, okay? And it says using the alternative formula. So look, guys, just so you can get an idea, they call it the alternative formula. It's still the law of cosines. It's just, yeah, you're looking for the angle. So this is what they're actually referring to. This is what they call the alternative form. It's just if you want to find the angle. So it's a squared plus b squared minus c squared over 2ab. That's equal to the cosine of c. So I'm going to come back over here and I'm going to write that down. I'm going to say cosine of angle c equals, oh, I already forgot it. Let me scroll back one more time just to double check. A squared plus b squared minus c squared. A squared plus b squared minus c squared all over 2ab. Okay. So again, this is going to be very much plug and chug. Cosine of c equals, we're going to go through slowly. A squared, this is 10 squared, plus b 8.7 squared, minus c 12.3 squared. All of this is over 2 times a times b. So far, are we okay at this point? Just a little plug and chug? Guys, let me ask you a question. How am I going to find my angle C? What do I need to take? If it's cosine, what do I need to do to get rid of the cosine just so that I can get the C? Say it again. Inverse cosine. Very good. Oh, yeah. Yeah. No. That was probably my bad here. Okay. All right. So again, y'all, I'm going to use my calculator. Let me move this over to the side. And I'm going to go, look, second cosine, oops, turn it on first. I'm going to turn it on. There we go. Okay, so we're going to go second cosine inverse, right? And look what we have. I got a whole bunch of stuff up here, okay? So this is what I'm going to do. I'm probably going to go 10 squared. Actually, you know what I'm going to do? I'm going to put this in parentheses because everything is going to have to be, it's all that top divided by the entire bottom. So 10 squared plus 8.7 squared minus 12.3 squared divided by 2 times 10 times 8.7. Close that off. And I think we're good there. Hit enter. Oh, I did something wrong. Let's go to. Maybe I need another one of these. Nope, something's still wrong here. Maybe the way I entered it in. 10 squared plus 8.7 squared minus 12.3 squared divided by 2 times 10. Oh, maybe, yeah, maybe that's what it is. Maybe I need to do this right here too. Second insert, parenthesis right there. Let's try that now. There we go. Okay, so we got it. Thank you, Thomas. So C, again, y'all, we're going to one decimal place. Would you say 81.9 or 82? 81.9. So C equals 81.9 degrees. Okay. Okay, so we found our angle C again using the law of cosines, right? So right here, y'all, I'm just going to zoom in real quick, and I'm going to write this as 81.9 degrees. Okay, so we got my triangle here. Look at step number 2. Step number 2 says find either of the two remaining angles either using the law of sines or the law of cosines. So we need to find either A or B. Okay, either A or B. So let's go ahead and find. It doesn't really matter which one we're going to find, whether we find A or whether we find B. Let's find A. Okay, so y'all, I'm just going to use my law of sines. Sine of A over A equals. I need to use the sine of C over C because that's the angle that we have. We don't have an angle yet for B, so I can't use that part of the law of sines. So we're going to say the sine of A over little a, which is 10, equals the sine of 81.9 over 12.3. And then again, y'all, I'm going to go ahead and multiply everything here by 10. So we can get rid of this part. And so this is going to leave me with the sine of A equals 10 sine of 81.9 divided by 12.3. And so A is going to be equal to, so remember, y'all, if we have the sine of A, the way we're going to get rid of the sine is we're going to take the inverse sine, right? So the sine inverse, or the inverse sine of 10 sine of 81.9 all over 12.3. Okay. And we should be able to find our angle A like this. Like that. Let me close this one. Okay, here we go. So clear this out. So again, I'm going to go second, sine inverse. Now it's opening up parentheses for me, so I'm going to go 10 sine of 81.9, close those parentheses, divided by 12.3. And I'm coming up with 53.6. Okay. And so we have one last part, y'all. We have to find the angle for B. Anybody know how we would find angle B? What do you think? What do I need to do to find angle B? Do I need to go through sine inverse? Do I need to do law of sines to find angle B, y'all? No. What can we do? Yeah, add A and C and subtract it from 180, so we can say 180 minus 81.9 plus 53.6, and we are coming up with 44.5. So we got it pretty straightforward, right? Okay, so let me keep zooming on through here, y'all, scrolling through, and let's take a look at problem number 3 and see if we can't figure this out a little bit. Let me do this, maybe it makes it a bit easier. Anywho, it says 2 planes leave the same airport. The first plane leaves at 3 o'clock and averages 450 miles an hour at a bearing of 70 degrees south, or south 70 degrees east. The second plane leaves at 5 p.m. and averages 510 miles an hour at a bearing of north 10 degrees west. How far apart are the planes at 6 o'clock and round to the nearest mile? Okay, so we're going to go really, really slow here, y'all. Okay. And so the first thing I'm going to do, I'm going to draw like my XY axis, because remember when we talked about bearing the other day, we kind of have to have an idea of what's going on. So let's take a look. South 70 degrees east. First question, is the plane going up or is it going down? Going down. Why? Because it's going in the southern direction, right? Okay, is it going down to the left or down to the right? How do we know? So take a look. It's set south 70 degrees east. So think of like a compass, you know, north, south, west, east. So we're going south, we're going down into which way? To the right, aren't we? Does that make sense? Okay, so look, we're going to draw a picture. So this is kind of what we have going on here, right? And you know what? I'm going to make that picture just a little bit better, because my angle is supposed to be what kind of angle? What's the angle that we have formed? Isn't it 70 degrees? Even that doesn't even look like 70 degrees. So let me draw it maybe more like this. There we go. Something like that, right? Okay, now let me ask you a question, y'all. The 70 degrees, is it this angle here or is it this angle here? What do you think, the red or the green? The red, right? Remember, y'all, the angle that when we're doing the bearing, the angle is always formed with the north-south line, okay, the line that's going up and down. So the red is the 70 degrees, okay? Second thing I want to do, I want to figure out how long is that stretch, okay? So didn't they give me some information? Didn't they tell me? So we know that the basic distance formula is like distance equals rate times time, right? You're going 70 miles an hour. You drive for 2 hours, you've gone 140 miles, right? So let's take a look. How fast are we going? 450. We leave at what time? 3 o'clock. And then we're going to check our distance at what time? How many hours have gone by? 3 hours. So anybody got a calculator? Can you do me a favor, y'all? What's 450 times 3? Yeah, 450, because that's how fast we're going. Times 3? 1350. Thank you, John. So we know that that distance right there, y'all, is 1350. Okay? Let me ask you another question. Before I go on, let me ask you one more question. I know that the angle in red is 70 degrees. What's the angle in the green? How much? How much? 20. Okay, I agree. Why is it 20? Has to be 90 degrees, right? Good, good, good. Just double checking, y'all. Okay, now, so we got the first part. Hey, we're doing good so far. Now let's deal with the second plane. So let's talk about the second plane. Second plane leaves at 5 o'clock, averages 510 miles an hour on a bearing of north 10 degrees west. Is that plane going up or down? Up. Is it going to the left or to the right? To the left. Perfect. So that plane takes off and it starts to do, oh man, that's a really crooked line. This plane takes off and it starts to do something like this, right? Y'all agree that the 10 degrees is that angle right there? Okay. What we're trying to figure out is how far apart are those planes, right? So look, what we're trying to figure out is how far is it from here, say to there. Do we know how far this blue line is? That plane left at what time? 5 o'clock. Okay. How fast was it going? 510 miles an hour. How long was it in the air? an hour because it left at 5 and we're checking the time at 6. So y'all agree with me that the time here or the distance right there is 510? Okay, so I'm going to ask you all a question. Oh man, what color can I use? Well, we already used green, purple. Let's see, do we have purple? Right here, purple. Okay, I'm going to ask you all a question. Can we find that purple angle? Yeah. So we already know that this much here is how much? 90 plus another 10. But you're adding 90 plus 10, 100 plus the green, 120. So we know that that green angle there, y'all, 120 degrees. So far, we doing okay? All right, guys. One thing I really want to emphasize. Notice how I'm doing this problem. I'm going slow. If I was going any slower, I'd be going in reverse, right? I'm trying to go real slow and just do one piece at a time. I know there's a lot in the problem, but if I do it in pieces, hopefully it makes it a little bit easier. So look, we know the blue line is 510. We know this black line here is 1350. We're trying to say find that red line, right? Okay, so I'll tell you what, I'm going to call this here, this big purple angle C, okay? We're trying to find little c. And I'm going to say that this blue one is little a, and I'm going to say that this black one here is little b. So according to the law of cosines, this is the formula. C squared equals a squared plus b squared minus 2ab cosine of c. Okay. That's just the formula for the law of cosines. It's there in the notes, right? But that's the formula for my law of cosines. Okay. And we already know most of these values. So look, I'm going to start writing it out. C squared equals a squared. We're calling a 510. So 510 squared plus b, which is 1350 squared, minus 2 times a, which is 510, times b, which is 1350, times the cosine of what angle? Cosine of 120. Very good. Okay. So again, y'all, all I'm going to do is pull up my calculator. Going to go in right here. Let me move this over to the side. So we got some room. Let's turn it on. Let's clear it out. And we're going to go piece at a time. 510 squared plus 1350 squared. Okay, minus 2 times 510 times 1350 times the cosine of, what was that? We said it was 120. Okay. And make sure I'm typing in everything correctly. It looks like it is. So I'm going to hit enter. And then that's giving me the answer for c squared. So we want to find c. What is it we need to do? Square root it. So we're going to go second square root of our answer. And I want to say, if you look at the directions right here, y'all, it says round to the nearest mile. So if we round this number to the nearest mile, means we're going to round to the nearest whole number. Would you say 1664 or 1665? There you go. You got it. So C equals 1665 miles. And we're able to figure it out. The one thing I really want to emphasize, y'all, in doing these type of problems, especially when it comes to like the application problems, I think when it's just asking you, can you solve this triangle? You kind of follow along. It's usually plug and chug. This is plug and chug too, but what helped me the most, honestly, draw the picture, especially because it was talking about bearings, right? And I got to remember, just like the compass, when you're looking like at a middle school map or whatever, north is this way, south is this way. From your perspective, here's west, here's east, right? You got to just know that kind of thing. But then once I draw my picture, then I'm able to figure out, okay, this is what I'm trying to find, this distance here, and can I find that big angle? And luckily, we were able to do that, right? Okay, so let me keep scrolling here a little bit more, and we're going to do the same thing, solve the same type of problem, using problem number 4, and it says the distance between Miami, Florida, New York City, and I'm sorry, the distance between Miami, Florida, and New York City is 1,093 miles. The distance from New York City to Nashville, Tennessee is 759 miles, and the distance from Nashville to Miami is 816 miles. We're trying to find the measure of the angle between the towns round to 1 decimal place. Okie dokie artichokes. So I'm going to zoom in here. All right. So we're talking about Nashville, New York, and Miami. Okay, so let's see if I can get rid of this part here. Close that part. I don't need it. All right. So which one is Miami? The south one. Okay, so we're going to go like this. I'm going to call that M for Miami. Which one is Nashville? The western one here is Nashville. And then we all agree that this is going to be NYC? Okay, so let's see if we can label this triangle. Okay, so first thing I notice is it says the distance between Miami and Florida is 1093. So everybody agreed that this distance here, y'all, is 1093? And then the distance from New York to Nashville is 759. So this one here is 759. And then the distance from Nashville to Miami is 816. So this one here is 816. Okay, so what we're going to do, y'all, we're going to start finding those angles, okay? So I'll tell you what, let's call this little, let's call this side little n. Let's call this side here little m. And let's call that little side there NYC. Okay. Just using the kind of the Law of Cosines idea. All right. So guys, the easiest way to kind of think about this is when you're thinking about the Law of Cosines, if you're using, say, this side right here, the angle that's going to be written is the angle that's opposite. Okay, so what I mean by that is if I were using the Law of Cosines, I would say n squared equals, I'm going to use these other two sides. And so I already know that my n squared is 1093, so I'm going to say 1093 squared. And since I'm actually, you know what, let me pause for a second. Since I'm trying to find, since I'm trying to find this angle n, I'm going to use one of those alternative forms. So the way I would do this would say cosine of n equals, give me 1 second, and I will tell you, should be 816 squared plus 59 squared minus 1093 squared. I'm sorry? Oh, 759? Yeah. Yeah, sorry about that. Oops, somewhere. 759, there we go, plus all over 2 times 816 and 759. Okay. And then remember, y'all, the way I'm going to find my n is I'm going to take the cosine inverse of all of this business right here. Alrighty, so let's see if we can get this thing here to work. So, turn it on, clear it out. First thing I'm going to do, cosine inverse. Okay, and I got a bunch of stuff here, y'all, so I'm going to start doing some parentheses. 816 squared, 816 squared, plus 759 squared, minus 1093 squared, divided by, and then I'm going to put parentheses 2 and 816 and 759. And I'm going to hit enter. And okay, so I'm coming up with my angle n to be, I think we're still going to 1 decimal place, 87.8, 87.9. .8. Okay, so we got 87.8. All right. So we know that that angle there, angle N, is 87.8 degrees. Okay, we still need to find the other two angles. So, y'all, we can do this a couple of different ways. One way we can do it, I would say, let's use the law of sines. The law of sines is just a much easier formula or easier process in doing it, but I have to know at least one of those angles, okay? So suppose I'm going to do it for the angle M, right? So I might say something like the sine of M over little m equals the sine of N over little n, okay? So the sine of M over little m would be 759 equals the sine of N, which we found to be 87.8 over the 1093. And then again here, y'all, I'm going to multiply both sides by 759. And so that's going to give me the sine of M equals 759 times the sine of 87.8 all over 1093. And so my angle M is going to be the sine inverse of all this fun stuff right here. Okay. So let me move this guy over here. And I'm going to clear my screen. And I'm going to type in exactly what I wrote down. So I'm going to say, look, I'm going to go second sine inverse 759 times the sine of 87.8, close my parentheses for my angle, divided by the 1093, and close those parentheses, and then hit enter. And to one decimal place, y'all, I'm coming up with 49 or 43.9. All right, so we need to find one more angle. We need to find the angle at New York City. So remember, the way we can find the angle at New York City is we can take these two angles and add them together and subtract it from 180. So 180 minus 87.8 and 43.9, and get those together, and that angle is coming up to be 48.3. And we found the angles between each of those three cities. So just something, y'all, I mean, this is just kind of like an observation. I'm just looking at the picture and looking at the angles. So look at angle M and angle NYC. So if you look at, like, say, this angle here and this angle here, one is like, if I were to say, like, I'm going to round it up to the next whole number, 44 and 48. So just by looking at the picture, and again, this is just observation, right? But doesn't this angle and this angle look to be almost the same? Like, it almost looks like they're kind of same. And I will say they're not, but they're almost the kind of same. And then doesn't this angle right here look almost like a right triangle? And a right triangle is how much? 90 degrees. And look at what we came up with. 87.8, right? So the picture is pretty accurate. You know, I know it's not 90 degrees, but the picture is pretty accurate in terms of how they drew it, right? And the angles that we came up with, right? Just a little observation there. Alrighty. So I think we got a little bit more. Here we go. Heron's formula. So guys, Heron's formula is a way that we can find the area of a triangle if you don't necessarily know the base and the height. And so if you remember this from high school, the formula for the area of a triangle was base times height divided by 2, or sometimes they'd write it as 1/2 the base times the height. But again, you have to know the base and you have to know the height. The height means that you have a right angle somewhere in there, okay? So this formula works regardless of whatever kind of triangle you have. And so Heron's formula says the way we can find the area of the triangles given the sides A, B, and C is, here is the formula for the area right here. and it's s, or it's the square root of s times s minus a, s minus b, s minus c, where s is something we call the semi-perimeter. So perimeter means add up all the sides. Semi-perimeter is add up all the sides and then take half of that number. Okay, so the question here says, let's find the area of the triangle formed by the three cities in the problem that we did before. We're going to round this to the nearest mile, or square mile. So we're going to come back over here, and we're going to see if we can find, number one, the semi-perimeter. So the semi-perimeter says we're going to take all the sides, 759, 816, and 1093. Oops. And we're going to add them all up, and we're going to divide it by 2. Okay, so let's do that. So 759 plus 816 plus 1093 is that divided by 2. Did you come up with 1334? Good. Okay. There's that part of my formula already. Second thing we need to do, we need to take that s and subtract each of the three sides with it, okay? So look, y'all, what I'm going to do is I'm going to write the formula for my area. So the first part says s. Well, we know s is 1334. The second part is going to be 1334 minus each of those sides. So the first time I'm going to go minus 759, 1334 minus 816, and 1334 minus 1093. Okay. And this right here, y'all, is going to be strictly a calculator problem. You don't even, I mean, you can enter this in exactly in the calculator as we see it, right? So let's go ahead and do that. So I'm going to go second square root. Okay, now it's opening up a whole bunch of stuff here. So I'm going to go 1334 times, I'm going to put parentheses, 1334 minus 759, 13, oops, parentheses again, 1334, oops, come on now, minus 816, and 1334 minus 1093. And I'm going to come back up here. I just want to make sure that it's going to give me parentheses for everything. I'll open those up. Yeah, we should be good there. Is this the number you're coming up with? 309,446? Okay. And it says we're supposed to round to the nearest mile, which means we're going to round to the nearest whole number. So would we round up to 6 or would we leave it alone? Leave it alone. Okay, so we came up with 309,446. Yeah, square miles, miles squared, however you want to write it, right? And that's it. So it's a pretty big number, right? 309. Almost, yeah, about 309,000 square miles, but that's also the area between New York City, Miami, and Nashville, Tennessee, right? So it's obviously looking at a big area there. Yes, sir. Like radicals?
Yeah. So the radical would be 230 times 181015.
Okay, say that again now. So I'm going to pull it up on my calculator.
230.
Where do you get 230?
This is the number that we're not.
Before you take the square root. Is that what you're saying?
No, this is the number. If you were to rewrite this whole 1334 business as like simplified, that's what it is. 230 times square root of 180.
Oh, okay, yeah. You're talking about when you actually break it down, like if you could simplify the square root, where you have a number on the outside and then a number on the inside of the square root. Yeah, that's what we call a simplified square root. That's an exact answer. But usually when it comes to like applications, when it usually comes to word problems, we want to know an approximation. But what you have is what we would call the exact answer, John. All right, so what do you guys think? Love cosines? Does it make sense? Good enough? It's pretty straightforward, right? It's a lot of, it really is a lot of plug and chug type of stuff, y'all. So that's actually all we have for the day. It was just 6.3. So guys, just a heads up. Remember, 6.1 is due by tonight. So if you haven't finished it, you want to finish that one tonight. 6.2, which is what we did this past Monday, that's due this coming Monday, and 6.3 is due a week from today. So I'm trying to give you guys plenty of time so that you have time to get everything done. I probably will be, so guys, if you when you go into Alex, you can always check the little grade book. You can always see what your grade is. But I'm probably going to upload our grades to Blackboard just so that there's something like official there. But your grades in Alex are always going to be more up to date than anything. Let me stop it.